work and energy both are interconnected, and we know that scientifically work is equals to F force dot as displacement cos theta. Work equals to Fs cos theta. Here, work equals to force into displacement into cos theta. This theta value, if you keep cos 0, this is 1. If you put cos 90, it is 0, and cos 180, it is minus 1. So we have three types of work. Positive work, so when force and displacement both are in the same direction, so we say this is displacement direction and this is force direction. So we say that it is positive work. So work equals to W plus Fs. Why? Because cos 0 is 1. So when you put cos 0, you get 1. So work equals to Fs. This is negative work when force is this direction and displacement is opposite to the force. So in this case, we say work equals to minus Fs. Why? Because cos 180, angle is 180 degree between force and displacement. So work equals to minus Fs. And third case, this is the first case, this is the second case, and we have third case when force and displacement both are making angle 90 degree. Example is circular motion. We know that in circular motion, displacement is here, and at this instant, displacement is, force is towards center, displacement is tangential. So angle is 90 degree. So here we say work equals to Fs cos 90, and we know that cos 90 is 0. So we can say that work equals to 0. That's why in circular motion work will be 0. So in summary, we can say that we have three types of work. F, S together, same direction, theta is 0. So work equals to plus Fs. If it is opposite, we say work equals to minus Fs, and if it is perpendicular, then we say work equals to 0. So we have in work this many concepts. If you want to do some questions, you can try. Suppose an object of mass is given 20 kg and acceleration is 5 meter per second square and displacement is 20 or 200 meter, you take 200 meter. So we can find the work Fs. So force is mass into acceleration into displacement. So mass is 20, acceleration is 5, and displacement is 200. SI unit is joule. Remember this. SI unit of work is joule. So you can solve it. Now next concept is energy. We know that SI unit of work is joule and SI unit of energy also is joule only. It means we can say that both work and energy are interlinked to each other. So energy and work both are interlinked, both have same SI unit. We have many types of energy: mechanical energy, electrical energy, chemical energy, nuclear energy. There are many types of energy. In this chapter we have only mechanical energy. So mechanical energy we will study here. Mechanical energy we classify into two parts. One is kinetic energy, and another is potential energy. So what is kinetic energy. Kinetic energy is related to velocity. So how to derive the kinetic energy formula? Very simple. We know that third equation of motion, v square minus u square equals to 2as. So from here we can say that v square minus u square by 2a equals to s. And work, we have seen work equals to Fs. Correct? Work equals to Fs. And we need kinetic energy, so we can write kinetic energy. And both work and energy both are same. Force is mass into acceleration, and S is from here we can say v square minus u square by 2a. So a cancel. So we got kinetic energy equals to half m v square minus u square. So this formula you have to remember. Kinetic energy is nothing but half m v square minus u square. What if initial speed is 0? We know that kinetic energy equals to half m v square minus u square. What if initial u equals to 0? Means object is at rest and then it is moving with some velocity. So it has u0. So we say kinetic energy equals to half m v square. This is very famous equation, kinetic energy. Whenever anything is moving with certain velocity, we can find the kinetic energy half m v square. Now, next we have potential energy. So potential energy is nothing but it's because of configuration. So here we'll see gravitational potential energy. Suppose this is the earth. This is one object kept up. It has some mass. It is on earth, so it has some gravity, and it is kept at some height h. So we know that work equals to Fs, and in this case F is ma, and A is g here, and S is h. So potential energy equals to mgh. We have two formula. Kinetic energy is half mv square and potential energy is mgh. Based on this, you can solve some numerical like if a car is moving with velocity maybe 54 kilometer per hour and has mass 200 kg. So how much energy is required, energy or work is required to stop the body, stop the car. So mass is given, mass is 200 kg and it is moving with velocity u is 54 kilometer per hour. We need to convert to meter per second, so we can convert 54 into 5 by 80 meter per second. 3. So you got 15 meter per second. Correct? We have mass, we have initial velocity, and finally it has to be 0. V equals to 0. Correct? So what we'll do? We'll use kinetic. We have to find kinetic energy because if anything is moving, it will have kinetic energy, which we know that half m v square minus u square. In this case, kinetic energy equals to half m is given already 200 kg car mass and u is 15 meter per second. So car mass is 200 kg and v will be 0 because finally it has to be in rest, and u we got 15 meter per second, so 15 square. So kinetic energy equals to 100 100 minus this minus 15 into 15 is 225. So we got kinetic energy equals to minus 22500 joule. So this is practical problem actually. If one car is coming which has mass 200 and it has some certain velocity 50 meter per second, if you want to stop it you have to apply some energy and that energy will be this much. This is the actual problem. Practically you can understand. So today we have seen potential energy, kinetic energy and work, and next class we will see some more numerical and conservation of energy.